In this video, we are going to discuss few problems on double and triple integration in polar coordinates. First problem, evaluate integral 0 to pi, integral 0 to 5 r power 4 sin theta dr d theta. In this problem, first we have to check the given limits. If the limits are constants as it is in the given order, we can integrate. Given problem, integral 0 to pi 0 to 5 r power 4 sin theta dr d theta. Here all the limits are constant, that's why we are going to integrate with r and theta. Okay, first integrate with respect to r. Here sin theta constant, sin theta into r power 5 by 5 into d theta. Limit will be 0 to 5. Now apply upper limit value 5 in r. Here 1 by 5 constant take outside, sin theta into 5 power 5 minus lower limit value 0 into d theta. Okay, 1 by 5. Here 5 power 5 constant take outside, integral 0 to pi sin theta into d theta. Okay, now we can remove 1 5. The value of 5 power 4 is 625. Integrate with respect to theta. Here integral of sin theta is minus cos theta with the limit 0 to pi. So 625 into, apply upper limit value pi cos pi minus lower limit value which is 0. 625 into, the value of cos pi is minus 1, the value of cos 0 is 1. Here this negative sign is common for both. In the lower limit one negative sign will come, no, which is plus here. 625 into minus plus 1 plus 1 2. Therefore the answer is 1250. 260 625 are 1250. Next problem, evaluate integral 0 to 2 pi, integral 0 to pi, integral 0 to a r power 4 sin pi dr d phi d theta. In this problem also all the limits are given, limits are constant only, 0 to 2 pi, 0 to pi, 0 to a only. In this problem you no need to check the given order, as it is in the given form we can integrate. In case if the limits are variable, we have to check the order. Given problem, 0 to 2 pi, 0 to pi, 0 to a r power 4 sin pi dr d phi d theta. First we are going to integrate with respect to r. Here sin phi constant, temporarily considered as constant. Integral of r power 4 is r power 5 by 5 with the limit 0 to a into d phi d theta. Now apply upper limit value a in r. 0 to 2 pi, 0 to pi sin phi a power 5 by 5, lower limit value is 0, d phi d theta. Okay, now we can integrate with respect to phi. Here 1 by 5 constant, a power 5 also constant, take outside, integral 0 to 2 phi, integral of sin phi is minus cos phi with the limit 0 to 5 into d theta. Okay, a power 5 by 5, integral 0 to 2 pi minus of cos phi minus of minus cos 0 which is plus here, because here one negative sign is there, in the lower limit one negative sign will come, it will be positive. A power 5 by 5, 0 to 2 pi. Before we integrate with respect to theta, first we have to simplify this one. Minus of cos phi is minus 1, plus the value of cos 0 is 1 d theta. Minus of minus 1 will be 1, 1 plus 1 2, 2 constant take outside, 2a power 5 by 5 integral of 0 to 2 pi d theta. Now integrate with respect to theta with the limit 0 to 2 pi. 2a power 5 by 5 into apply upper limit value 2 pi in theta minus lower limit value 0. Therefore the answer is 2 2s are 4, 4 pi a power 5 by 5, okay, which is the correct answer. Next problem, evaluate integral 0 to pi integral 0 to a sin theta r into d theta dr. Okay, in this problem the given limits are variable limits. Okay, each and every problem first we have to check the given limits. In this problem the given limits are variable limits. The inner limit is 0 to a sin theta. Here r and theta variable. Okay, r and theta variable. Outer limit 0 to pi, okay, constant. Always our outer limit will be constant only, but in the inner integration we are having variable limit. Theta here variable limit. Okay, zero to pi, 0 to a sin theta. Here theta variable is there, which means first we have to integrate with respect to r. We have to take r into dr d theta. We have to take the opposite variable only. Okay, first we have to check the given order, and then in the as usual way we can integrate one by one. Integral 0 to pi, first integrate with respect to r. R square by 2 with the limit 0 to a sin theta d theta. Here 1 by 2 constant take outside and then apply upper limit value a sin theta in r, which is a square sin square theta minus apply lower limit value 0, which is 0 only, into d theta. 1 by 2, here a square constant take outside, a square into 0 to pi sin square theta d theta. Now we are going to integrate with respect to theta. A square by 2, but we can't integrate directly. We know that the formula, which is sin square theta equal to, we can write 1 minus cos 2 theta divided by 2. With the help of this formula we can integrate easily. Substitute here 1 minus cos 2 theta by 2 into d theta. Okay, now we are going to integrate with respect to theta. The denominator 2 constant take outside. Already we are having here 1 2, which is 4. Integral 0 to pi 1 minus cos 2 theta into d theta. Okay, now a square by 4, integrate with respect to theta, which is theta minus integral of cos theta is sin theta. Here 2 theta is there, sin 2 theta divided by 2 with the limit 0 to pi. A square by 4 into, first apply upper limit value pi in theta, pi minus sin 2 pi by 2, then apply lower limit value 0 here, minus 0 minus sin 0 by 2. Now a square by 4 into pi minus the value of sine 2 pi is 0. This become 0, sine 0 also 0. Therefore, pi a square by 4 is the final answer. Okay. Okay, next problem. Find the area bounded by the circle r is equal to 2 sin theta and r is equal to 4 sin theta. Okay. Now we are going to find the area for the given curves. Okay. The first thing we have to write the formula. Area formula is double integral r into dr d theta. Okay. You should remember this one. In Cartesian coordinates, we used double integral dx dy or dy dx. In polar coordinates, you should remember double integral r into dr d theta. Okay. First, we are going to draw the diagram for the given curve. R is equal to 2 sin theta and r is equal to 2 cos theta. Okay. In Cartesian form, we used the x-axis, y-axis, but here we are going to use the theta equal to this one 0 line, theta equal to pi by 2 line, theta equal to pi line. Here theta equal to minus pi by 2 we can take. Okay. First curve is r is equal to 2 sin theta. Okay. Which is a circle, but we need the shape of the circle, which means the center and radius of the circle. See, look at this. Here r is equal to 2 sin theta. If you put theta equal to 0, okay, if you put theta equal to 0, we will get r is equal to 0 because sin 0 0. Then put theta equal to pi by 2. Okay. If you put theta equal to pi by 2, we will get r is equal to 2 because sin 90 is 1. Sin pi, value of sin pi by 2 is 1, we will get 2. Okay. First value theta 0. Theta 0 means we have to mark in this line. Okay. Here in this line, r is equal to 0. We have to start from here, origin. And then if we put theta equal to pi by 2, we are getting r is equal to 2. R is equal to 2 means if we take 1, 2 likewise, we are getting here this point. Okay. In this line we have to mark, this line is the theta equal to pi by 2 line, we have to mark r is equal to 2 here. In case if we put some any value in between this theta and pi by 2, in case if we put here theta equal to pi by 4 means we will get the point here. Okay. This line is theta equal to pi by 4 line, we will get the value here. Okay. And then if we join the points, we will get the circle like this, which is the r is equal to 2 sin theta circle. Next one is r is equal to 4 sin theta. Okay. Here 4 sin theta. R is equal to 4 sin theta. The same thing in the place of 2, 4 will come, we have to take one big circle. Here 3, here 4 will come. Okay. Okay, this is the diagram. Now this is our bounded area. And then draw the radial line. In Cartesian coordinates we used a strip. Here we will use radial line. Okay, our bounded area covered first and second quadrant. Okay, first and second quadrant, and also using that we can draw the radial line like this. In any direction we can draw this line. First we are going to write the outer limit, that is theta limit. In polar coordinates always our outer limit theta limit only, that is constant limits. Okay, constant limits. Here our bounded area covered from 0 to pi. Theta equal to 0 lower limit and theta equal to pi upper limit. Okay, and then calculate the r limits. R limits. This radial line also like a strip only. This one end, our bounded area, this much area. Here this radial line lies this side. R is equal to 2 sin theta circle. Lies on the r is equal to 2 sin theta circle. Other end lies on the r is equal to 4 sin theta circle. Okay, therefore we can write r varies from 2 sin theta to 4 sin theta. Here theta varies from 0 to pi. Okay, we know that the formula to find the area in polar coordinates, double integral r into dr d theta. This is common for all the polar coordinates problem. Now we are going to write the limit 0 to pi integral 2 sin theta to 4 sin theta r into dr d theta. Okay, now integrate with respect to r, which is r square by 2 with the limit 2 sin theta to 4 sin theta d theta. Here 1 by 2 constant take outside, integral 0 to pi. First apply upper limit value in r. R square is here, which means 4 square is 16 sin square theta minus 2 square is 4 sin square theta into d theta. Okay, 1 by 2 into integral 0 to pi, 16 sin square theta minus 4 sin square theta will be 12 sin square theta d theta. Okay, here 12 constant take outside, 12 by 2 integral 0 to pi sin square theta will come. We can't integrate directly, but we know that the formula sin square theta equal to, we can write 1 minus cos 2 theta by 2 into d theta. Okay, this will be 6 by here 1 2 is there, take outside, integral 0 to pi 1 minus cos 2 theta into d theta. 6 by 2 is 2, 3. Integrate with respect to theta, which is theta minus integral of cos is sin only, but here cos 2 theta is there, which is sin 2 theta divided by 2 with the limit 0 to pi. First apply upper limit value pi here in theta, pi minus sin 2 pi by 2, then apply lower limit value 0, minus 0 plus sin 0 by 2. Okay, 3 into pi minus the value of sin 2 pi is 0, sin 0 also 0. Therefore, the final answer is 3 pi. Okay.